Okay, so I'm making a video on 5.4's homework. So you'll be given a problem, and they're going to say to construct or to make a polynomial that satisfies these characteristics. So here's what I want. I want it to be a fourth degree. Okay, so that means my f of x is going to have some x to the fourth something in there. Okay, I know whenever I multiply it all out, it's going to be x to the fourth. Now, the fundamental theorem of algebra tells us that every f of x that we can think of can be written as a form where I have some number multiplied by x minus some factor, x minus some other factor, x minus some other number, whatever, and I just keep going, okay, as many as I need. So that's what the fundamental theorem of algebra tells us. That if it's a degree n or degree 4 in this case, then I've got 4 of these factors that I can, let me not use f, let me use like g, okay? So I need 4 factors. Now, what do they tell me? They tell me that there's real coefficients, so no imaginary numbers, and the zeros are these numbers right here. So that means that x equals 3, x equals 4, and x equals I are zeros, okay? Now, degree 4 tells me there's 1, 2, 3, 4 of them, but I've only got 1, 2, 3. So what do I do? Well, first I need to solve for the 0. So how do I do that? Subtract 3 on both sides here to get x minus 3 equal to 0. That's one of my factors. This next one, minus 4 on both sides, okay? And I get x minus 4 equal to 0. This one, I here, this is an imaginary number. If you remember, I is equal to the square root of negative 1, okay? So look, anytime I have a complex number as a real solution, or as a solution, as a 0, then I also have what's known as a conjugate pair, okay? Conjugate pair. So if I have some real solution or some 0 that is a plus bi, then I get this one for free, a minus bi, okay? So right here I'm told that x is equal to I. That means that I also must have x equals negative I, okay? So I have an x equals I and an x equals negative I. That's that conjugate pair. One is a positive and one is a negative, okay? For that particular one, the a, the real component, is just 0, like it's 0 plus I, so it's not really doing anything. So if I minus I from both sides, I get x minus I equal to 0. And this second one here, okay, what is it? It's x, and then if I add I to both sides, I get x plus I equal to 0. Okay, so now I have all 4 factors. F of x equals x minus 3 times x minus 4 times x minus I times x plus I. This thing told me that I wanted real coefficients. Okay, told me I wanted real coefficients. Oh, I've forgotten something. I need to have my a right here just like it's here. That's a constant. And so right now I've got imaginary. So let's multiply those conjugate pairs together and see what we get. FOIL, first, outer, inner, last. First is x times x, which is x squared. Outer, x times I, which is xi. Inner, minus xi. And then last, negative, and then I squared. Okay, the good thing about when you multiply conjugate pairs is the imaginary component disappears. This goes to 0. So I get x squared, but then what is I squared? Well, if you think back, I is equal to square root of negative 1. So I squared is square root of negative 1 squared, which is -1. The square root cancels the square, and I just get -1. So this is minus a -1. So minus a minus makes a plus. So that is what this factor becomes here. So this nasty thing turns into x squared plus 1. Can I multiply these two together and simplify this a little? Sure can. Okay, I sure can. If I do that, I might have a little bit more difficulty trying to figure out what A is. So first, let's try to figure out what A is, okay? So what am I told? F of 2 is equal to 5. F of 2 is equal to 5. So what do I plug in for x? Just think about that for a second. Everywhere I see an x, what am I going to plug in? I'm going to plug in a 2. Okay? So f of 2 is equal to a times, and then I plug in 2 minus 3, and then 2 minus 4. And then what did we say this equaled? It equals this down here. So that's 2 squared plus 1. So what is f of 2? It's equal to 5. So this is 5 equals a. Now this is -1. This is -2. And this is 5. So multiply that out. You get a times negative negative make a positive, 10a. So divide by 10. So that tells me a is equal to 1/2. Okay? So my answer, f of x, is equal to 1/2 x minus 3 times x minus 4 times x squared plus 1. All in parentheses for each one of those. Right? And if you get to that part on the test, I'm good with that. Some teachers might say, multiply all of this out. I'm not really testing you on how to multiply at this point. I'm just wanting to know, can you figure out a formula for f of x? Okay. So another type of question that you might run into in 5.3 is sketching the graph. And this is definitely something that pops up on some tests at some point. Sketch graph, at least this idea, of f of x equal to x plus 3 times x minus 1 squared, and then times x plus 5 cubed. Okay? So how do we sketch the graph? So kind of a checklist for you on how to sketch a graph. Okay? So maybe I should put a little sticky note over here. Let's do that. Why not? All right. I think that's good enough. Okay. So it's not going to be perfect to scale, but kind of get the idea. So I've got my f of x and my x-axis here. Now, to do this, we need to know in behavior, am I going up to positive infinity? Am I going down negative infinity, right hand and left hand behavior? So how do I do this? I need to be able to have a lead term. So you can do it two ways. You can either do it with my trick, where we look at the individual factors and see how many copies, the multiplicities of each, and multiply it out. Or you just literally multiply everything up here. If you do that, you're going to spend a whole heck of a lot of time multiplying, and chances are you might make a mistake. So I'm telling you, doing it this way is going to save you. With the first factor, it's degree 1. the lead term is x, so I'm gonna multiply. I'm gonna multiply x how many times? 1 time. Okay. What's the lead term for the next one? It's an x again. How many do I have? I've got 2 of them, so I do x and then I do it twice. What is the lead term here? It's an x again. How many do I have? I've got 3 of them, so I'm going to do x and I do it 3 times. And now to get the lead term, I multiply all those dominant terms, individual dominant terms together, and I get x times x squared is x cubed, and then times x cubed again. So that's 1 plus 2 plus 3, which is 6. So the lead term is x to the 6. X to the 6, this is even. Even is the same. So either they both go down or they both go up. I don't know yet. Well, I kind of know. How do I know if they go down or up? The number in front, the lead coefficient is a 1. It's positive. So I'm going up to positive infinity on the right-hand side. And since it's even, it agrees. So I'm going up to positive infinity on the left-hand side. So let me erase these other ones here. All right, cool. So I want to look at the multiplicity for each one. So f of x is equal to x plus 3 times x minus 1 squared times x plus 5 cubed. The multiplicity for this first factor, how many x plus 3 factors? There's only one of them. So the multiplicity is equal to 1. Okay? What is my 0? Well, it's x plus 3 equal to 0 gets me what? If I solve for x minus 3, I get x equals negative 3. So at negative 3, all right, I have a multiplicity of 1. If my multiplicity is 1, then that is an odd multiplicity. Odd multiplicity tells me that I pass through, I cut through, I cross the axis. Okay? I cross the axis. I don't touch, I cross through it. So I'm either crossing through like this or I'm crossing through like this. Now, the multiplicity is 1, so that tells me that I do not flatten out. I don't flatten out. I only flatten out if multiplicity is greater than 1. Flatten out when multiplicity is greater than 1. Okay, if your multiplicity is greater than 1, then you're going to flatten out. Okay, so I don't flatten out for that one. For the next one, I see that I have a multiplicity equal to, well, how many are there? How many copies of x minus 1? There's 2 of them, so the multiplicity is equal to 2. So I take x minus 1, right? That factor squared equals 0. Solve for x, square root. So I get plus or minus 0, which is still 0. And so to solve, I get x equals 1. So that's another one. So right here is another solution. However, this one has an even multiplicity. Even multiplicity tells me that I bounce. Okay, I bounce, which the word we use in here is touch. So I come down and I touch the axis and I go back. Or the other way, I come down, I touch the axis and I go down, right? So that tells me to touch it. Do I flatten out? The multiplicity is 2. It's greater than 1, so I do flatten out. What do I mean by flatten out? As I come in close to the 0, what's going to happen? I sort of flatten out, and then I come back up. You think about it, anytime it's even, I'm going to bounce. Well, if I'm bouncing, I'm always flattening out around that root. Okay? All right, the last one here, is x plus 5 cubed. This has a multiplicity equal to 3. There's 3x plus 5s, okay? If I solve for x here, what would make this 0? If I plug in a negative 5, I think that will get me 0. So if I plug in a -5, I'm going to get 0. Okay? So right here. Now my multiplicity is odd. So what does that tell me? I cross. Now, I don't just cross through it like this, kind of like with the red one, x equaled -3. I actually flatten out as I cross. Why do I flatten out? The multiplicity is greater than 1. Your multiplicity is greater than 1, you flatten out. Okay, multiplicity is greater than 1 for those two factors. So let's see if we can draw this bad boy. Okay, the end behavior tells you kind of where to start, okay? So I like to go from left to right because that's how I read most days. So what is this first root I'm going to run into? It's my -5, 0. Okay, and what do? I come in, I cross it, but I flatten out as I cross. So I'm coming in from infinity, positive infinity, and when I come in, I flatten out. So I'm going to bend it a little bit. As I flatten out, I bend it a little bit, and then I straighten back up. So you see that? See how it flattens out a little bit? Okay. And now I'm going to come back up because I know I've got to cross to the red part. The red one is this one here. I'm going to cross again because it's an odd multiplicity. But since the multiplicity is 1, I don't flatten out. So I just go straight through without bending. So that's what I'm looking for, going straight through without bending. And then what am I going to do? I don't know if the hump is going to be before or after the y-intercept. By the way, this is not to scale. The y-intercept is not 3. Okay, I don't know what it is yet, but we'll figure it out. And then I come back down, right? Okay, let me come back down. And then what do I do at this 0 here? Well, it's an even multiplicity, so I touch it. So I'm coming down, I come down, I touch it, I flatten out, I touch it, and then I come back up. And I shoot off to infinity here. So that's what I'm looking for. I'm looking for when I'm coming in. So this is a root, x equals -5. I come in, I flatten out. Right? As I get close to my 0, I flatten out. And then at x equals -3, I come in and I go straight through it because the multiplicity is 1. And then I come back down. And when I get close to this root of x equal 1, I flatten out, and then I shoot right back up. If it's an odd multiplicity, I cut through it. If the multiplicity is 1, then I go through it, straight through it. If the multiplicity is greater than 1, I try to flatten out as I go through it. I just try to flatten out. If the multiplicity is even, then I bounce. I come down and I bounce and I go right back up. I don't cut through it. I just bounce. All right, guys. I hope that that's helpful to you as you work through these problems. Good luck.